This is a video for OCR Pure Core Mathematics, Calculus 4, Integration Techniques, 4.2, Further Integration using arc tan x. Consider this integral. I've got 5 over a quadratic expression. The only integral that we know that looks like this is this one, 1 over a squared plus x squared, which comes out at 1 over a arctan x over a plus c. Remember that arctan is the inverse tangent, and sometimes you'll see it written as tan to the minus 1 of x over a. Going back to our integral then, what we've got on the bottom here is not the same as we've got here, but this can be transformed so that we get it into this format. And once we have it in this format, we can then look at using the standard integral. Okay, so here's the integral. What can we do with this? Well, the first thing to note is I've got here 2 lots of x squared, and my standard integral only has 1 lot of x squared. So I'm going to take a factor of 2 out of the denominator. I've also got a 5 on the top. And again, in my standard integral, I have only 1 on the top. So I'm going to take a factor of 5 out of the numerator. So I'm going to get 5 over 2. That's removing both of those factors. 1 on the top now. And 5 over 2 plus x squared plus x dx. Now I'm going to do a little bit of work on the bottom line here, because I'm going to complete the square for these bits. So I've still got the 5 over 2, and then x squared plus x has come from x plus a half squared. If we multiply back out x plus a half squared, I get x squared plus x plus a quarter. So I need to take a quarter off to bring that back. And now I can release the outer set of brackets here and see what comes out. So I've got 5 over 2 minus a quarter. Well, that's 10 over 4 minus 1 over 4 is 9 over 4 plus x plus a half squared. Okay, there's that working tidied up. Here's the 5 over 2 taken out. Here's the completing the square, and then the final rearrangement to get an integral that's almost in the standard form. Okay, so how do we tackle this integral? Well, if you've seen the previous video about using arc sine, you'll know that our technique here is to let u equal x plus a half. And that means that du by dx is equal to 1. So when I do the substitution, du is equal to dx. So I can now do the substitution. This is going to be 5 over 2, the integral of 1 over 9 over 4 plus u squared du. Think about the standard form then and compare it with that. The standard form is 1 over a squared plus u squared in this case, because that's what we're using as our variable. And this is identical when a is equal to 3 over 2. So we can quote the result for this integral then. I need the 5 over 2 copied through from here, and then the result here is 1 over a, so that's 2/3. Inverse tan, so that's arc tan u over a, so that's u times 2 over 3. And that's plus a constant. I can tidy that up just a little bit. The 2's will go here. So I'm going to get 5 over 3 arc tan 2u over 3 plus c. But I know from the top line that u is equal to x plus a half. And so I can substitute that back in to give me that my integral, so this is the original integral here, 9 over 4 plus x plus a half squared dx, is equal to 5 over 3 arc tan twice x plus a half over 3 plus c. And of course we can do a bit here as well, so actually that gives me 5 over 3 arc tan 2x plus 1 over 3 plus c. Okay, so there it is tidied up for you. Down here we've worked the integral through in terms of u, and then down to our final result down here. We should perhaps ask ourselves if we could do that without using the substitution, and we've got over here, we've got du by dx is equal to 1, and that's always a good thing when we're trying this out. Go back to the original rearranged integral that we've got here, and inside the bracket, if you just hold that as a thing for a moment, as a blob squared in here, then this is really 1 over a squared plus something squared. And that should give me 1 over a arc tan this thing over a. Let's look at our result. In this first bit here, we've got the 1 over a arc tan, and then here we've got that thing from the thing squared over a. So in fact we could, with practice, we could see that we could do that without using the substitution. So in summary then, we take out the factors to give a numerator of 1 and a coefficient of 1 for x squared, and if you remember, we took out a 5 from the top line and a 2 from the bottom line. We then complete the square of the remaining expression, and our completing the square actually gave us x plus a half squared minus a quarter. So we use that. We then did do a substitution. We substituted u equals x plus a half, the thing that appears inside the square here. We used the standard integral, which was arc tan, and then we reversed the substitution to get an expression back in the original variable. And as I said on the last slide, this section here, where we do the substitution and the back substitution, that can be omitted after you've practiced the technique a bit and can see how the result is going to turn out. The next video in this sequence is 4.3, substituting x equals sine u.